So in the last session, I have explained that stack theory as well as implementation program. Now in the same way, first I am going to explain about that queue theory as well as that coding part. So based on that, you have to write the code just like how we define that stack. So what is the difference between a stack and queue? Stack means what? We are representing in a last in first out format, like what you push last, so that will come first. The operations, either you are push the element or you pop the element, pop the item, everything from the top of the stack. Either you push the element or you pop the element from the top of the stack. And we know that initially the top value is a -1. Top value is a -1. And in the same way, now it is a queue. Queue is nothing but first in, first out. Is a first in, first out. Just like a normal queue. Think like a normal queue, that elements you are inserting from the rear. If the queue line is there, that people are inserting into the queue. People are inserting into the queue from the rear. From the rear. This is rear. Rear is for insertion. And the people will travel like this. And once you get, here it is, they will get the information from the front. This is a very, very important one. Is a front location. This is always fixed location in the queue. Just like consider, there is a counter at box office. Suppose ticket counter is there. That counter will not move. The counter is a fixed. So that front location is a fixed. That people will go out of the queue. Will go out of the queue. This is what a front, and this is for deletion. This is for deletion. But here it is a two variables you need to take. So one is a front and second one is a rear. That a very important point is what? Front is always fixed. So you fix the value 0, but rear value is not fixed. Just like the top, you can start with the -1 because initially no elements in that queue. Initially, no elements in that queue. This is the one we need to write first. I'm just sharing. So based on that, you can write. Here now, how can we create that queue and all one by one, I'll explain. So once again, I'm telling clearly, whenever you are creating that queue, just like a stack with a fixed size, you can create. Suppose here I'm giving that size is of 5. I'm giving that size is of 5. Size is 5. Just like that stack. And here it is what? So index is 0, 1, 2, 3, 4. 2, 3, 4. And please use this fixed value. Front equals to 0. We should not change. Because of this fixed value only, circular queue and double-ended queue also introduced. The limitations of queue we'll see. So then you will understand why circular queue introduced actually. Okay. Only that rear value will change every time. Just like how the top value will change. Rear value is a -1. This is for saying simply that the queue has no elements. The queue has no elements. Simply to say, How can you say that Q is empty? How can you say that Q is empty? That simple one, if that rare value equals to -1, then we can say that it is empty. It is empty. That is the one. So now we are inserting the data. We are inserting the data. Insertion operations we are doing. Insertion operations we are doing. How can we do insertions? Insertions. We are inserting through rare. We are inserting through rare. That element we are reading, simply we are writing rare equals to rare plus 1, increasing the rare value by 1 into that location into Q of rare, we are inserting that element. So whatever the element you are inserting, that is simple message I'm using, inserted. Simple message I'm using, inserted. This is the one. This is the one. So we keep on doing insertions. Rare of 10, suppose consider. Rare of 10, suppose. Rare plus is equal to 1. Then Q of rare. Q of rare means what? Rare value -1 becomes 0. Into that 10 will be inserted. Next, rare of 20. Again is a rare plus is equal to 1. That Q value become 1 into the 20. Like this. Like this. Rare value, suppose 50 is inserted. Rare plus is equal to 1 will become Q of 4 is a 50 inserted. So first, rare value become 0. Into that 0th location, 10 inserted. Next, rare value become 1. Into that 20 inserted. Rare value become 2. Into that 30 inserted. Rare value become 3. Into that 40 inserted. Please mute yourself. Please mute yourself. Rare value is a 4. Here it is a 50 inserted. Now it is a full actually. So the same condition like a stack. I'm just writing here. Q is full. Q is full. When rare reaches this 4, nothing but here it is a rare equal to size -1 because size is a 5 here. When size is a 5, we can store up to 4 elements. We can store up to 4 elements. So simply if that rare value is reaches as a total size -1, we can say that Q is full. Q is full. This is the way we are writing the things. Let me explain. Right. Here it is. Now based on that, we are writing the codes. Based on this, we are writing the codes. How? Simply, whenever we keep on inserting, in this one, in this one, first we have to check queue is full or not. If queue is not full, we are inserting the data. If queue is not full, we are inserting the data. Now here, deletion and printing. Suppose if you want to display the information, display queue elements. How can we display the queue elements? First, we have to check same story, whether it is empty or not. Because if the queue is empty, you cannot display the information. So we are checking that. We are checking if queue is empty means what? If rare is pointing to -1, we can say that queue is empty. We can't display. Else, then we are printing that queue items are. Queue items are. From where to where? Front is always fixed. We need to start from 0 to not end is a 4. 4 is a rare. Because last element is always is a rare element in the queue. Last element is always rare element in the queue. So starting from either you write a front or you write a 0. So I'm repeating that loop for I in the range of starting from the front up to that rare +1. This is important that you know already simple things. Because if rare is a 4, you should specify 5. So then only it will stop at 4. As we are print, Q of I is print because I value starts from the 0, is nothing but from the front. Front is always 0. This is what displaying the Q elements is a Q elements. Sir, for example, I want to display the peak element. It is also same. Always that front location element will display. That's all. It's the same story first. Whenever you are finding the peak element, whenever you are finding the peak element, we need to specify that. We need to specify that if Q is empty, nothing but if rare equal to -1, we can say that Q is empty. If not, then directly you can print. So what is the peak element? What is the peak element? That is Q of rare. That is what? Sorry, Q of front. The Q of front. Front location element. Front location element is always the peak element. Front location element is always the peak element in that list. See, all these are common things. Just like how we specify all these things, how we specify all these things in the stack. In the same way, we need to write all these things in a queue also. But only one important discussion is that is called POW. For this, so normal thinking is important. If you see examples in internet or in a textbooks, what they will do, after deleting this one element, simply they will make front value is a 1. They will do front plus plus. That we should not do. That we should not do in linear queue. Remember that In linear queue, front is always fixed. Here we are learning that linear queue, that front location is fixed. Because of that reason only, they introduced what? Circular queue. That is what? Circular queue. In circular queue, that front location is not fixed. Front location. So wherever it is, suppose if front equals to 0, this value is not fixed. It will change. Once you delete that element in that front location, then front will move to that next location. But here, sir, in linear queue, suppose you said that front value is a fixed value. Then suppose if you delete the element, nothing but delete the item, then what will happen? Here it is a simple, normal thinking is important. Just normal thinking. Suppose you entered into one queue line. Consider you are in one queue line. The person who is at the counter, at the box office counter, the person who is at the counter got the ticket, movie ticket. Then the person will leave that queue. As soon as the person will leave the queue, what will happen? All the people will make a move towards the counter. Right? All the people will make a move. So that is the one we need to do here. We need to do here. Whenever you are deleting this front location element, when you delete 10, then what will happen? Simply, all these elements will move to this location. This one, this one, this one. All elements will switch. This switching only will take so much of time. This switching only will take too much of time. Remember that. So how can we do? How can we code for this one? How can we code for this one? It's the same. It's a pop. Pop is nothing but delete. Delete item. It's the same story here also. First, we have to check if the rare value equals to -1. -1, we can say that Q is empty. Q is empty. Else, first you can say that items deleted. First, you can print that Q of front location element is deleted, suppose. Then all elements you have to switch. Sir, from where to where? From first location to rear location. First location element should go to the 0th location. Right? From first location to rear. First location element will go to this 0th location. Second location element should go to that first location. Here it is third location element will go to second location. Fourth location element will go to third location. Finally, rare person will come front. For that, what is the code? It's a for loop only. For I in the range of starting from 1 to rare means what? You have to give rare plus 1. Okay. For I in the range of 1 comma rare plus 1. So every time into I minus 1, you have to store I value. I value. First, what is that I value starts with 1. So that first location element will come to 0th location because I minus 1 means what? This one. Next one, I value will increase. I value become 2. Then second location element will come to this first location. Next, third location element will come to this location. Next, fourth location element will come to this one. Then simply after this for loop, a very, very important concept, rare value you have to decrease. Minus, minus. Sir, why rare value you have to decrease? Because the person will come, no? Come friend. Now rare is pointing to 3. Rare is pointing to 3. But sir, still 50 is there. I already told you. We will not delete the data. We will not delete. So suppose next time if you insert the data, that 50 will be inserted with the new value. That is, so what we do, we just make the pointer is not pointing to that location. We will write the code in this way. We will write the code in this way only. So in linear queue, what is happening? Simply every time in linear queue, that front location value is a fixed. So that's why after every deletion, here we need to shift the elements. Shifting elements. This shifting elements only takes so much time. So much time. That is the only limitation in the linear queue. To avoid that one only, they introduced what? They introduced the concept of a circular queue. The concept of circular queue. This is the one. So exactly how we have written the code for stack in the last session, using that knowledge, you please everyone complete that code for the queue today and drop in that group, WhatsApp group, so that I'll combine now.